Now let us discuss the 8-point DIT FFT butterfly diagram. We won't derive this butterfly diagram, but as we discussed earlier, we have to remember few points regarding DIT algorithm. In DIT algorithm, we should draw the input in bit reverse order, and that bit reverse order is 0, 4, 2, 6, 1, 5, 3, 7. Then you have to draw small butterflies at the left and bigger butterflies to the right. Then you have to remember few twiddle factor values. Starting from right, you have to remember W raised to 0, W raised to 1, W raised to 2 and W raised to 3. These 4 consecutive values you have to remember. And at the right hand side, here you have to remember the 2 alternate values out of these 2, that is W raised to 0 and W raised to 2. W raised to 0, subscript W raised to 0, W raised to 2, W raised to 0, W raised to 2. So these values you have to remember. And then remember there are 4 minus sign here, minus 1, minus 1, minus 1, minus 1, 4 minus sign here, 4 minus sign here, and 4 minus sign here. And the output is in normal order. For n equal to 4, we already derived. Here you have to remember only 2 twiddle factor values, W is to 0 and W is to 1. Small butterfly at the left, bigger butterfly at the right. 2 minus sign here, 2 minus sign here. Bit reverse order here, normal order here. And the 2 twiddle factor values you have to remember for n equal to 4 is W is to 0, that is 1, and W is to 1 is minus j. And the 3 twiddle factor, in fact 4 twiddle factor values you have to remember for n equal to 8 are W is to 0, that is 1, W is to 1. Here the real axis is positive, imaginary axis is negative, so we have to say that W is to 1 is 0.707 minus j 707. W is to 2, imaginary axis negative, minus j, real axis 0. W is to 3 is both real axis and imaginary axis are both negative, so it is minus 707 minus j 0.707. So these 4 values you have to remember, other values you need not remember. And if you put those all things here, the 8-point DIT FFT diagram look like this. And let us solve one example. Given x of n, you have to find its 8-point DFT. So what you have to do to find the DFT, you have to first of all find the bit reversal order. So first of all, x of 0 you should find out. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6 and 7. So first of all, note x of 0 and x of 4 right here. 1, 0. I'll change the color. 1 and 0. Then 2 and 6. 2 is 1, 6 is 1. So 1, 1. Then you require 1, 5. 1, 5, 2, 2. And you require 3, 7. 2 and 7 is also 2. So I noted the bit reversal order. Here you have to perform the arithmetic. It is 1 plus 0, so here I get 1. 1 minus 0 is 0. 1 plus 1 is 2. 1 minus 1 is 0. 2 plus 2 is 4. And 2 minus 2 is 0. 2 plus 2 is 4. And 2 minus 2 is 0. Here I require some complex multiplication. 0 into minus j comes out to be 0, and 0 into minus j also comes out to be 0. Here I get 1 plus 2, that is 3. Here I am getting 0 from this branch, and from this I am getting also 0. So I think we have made mistake here. Here it should have been 1 minus 0, that is minus 1, and I should say here I should get here minus 1 plus, so it should be plus 1, no, sorry, so it should have been plus 1 minus 0, that is plus 1, so I should say here it is plus 1, and here I should get 1 plus 0, that is 1 plus 0 is 1 here, then here I should get 1 from the upper branch and minus 2 from the lower branch, so that gives me minus 1. Here I am getting 1 from the upper branch and 0 from the lower branch, so I should get plus 1 here. Here I am getting 4, and here I also am getting 4, so it gives me 8. Here I am getting 0 from this branch and 0 from this branch, so I should get 0 here. Here I am getting 4 from this branch, and 4 multiplied by minus 1, that is 0 here also. Here I am getting 0 from this branch and 0 from this also, so I get a 0. So I have to multiply now. 8 into 1 is 8, 0 to something is 0. Here I am getting 0, here I also am getting 0. Product of 0 into something is 0. And now I can say that output of this branch, output here will be 8 here, 8 plus 3, that is coming from this branch, so that is 11. Here I am getting 1 from this side, so 1 here, 1 from this branch and 0 from this side, so I should say it is 1. Here I am getting minus 1 from this branch, and from this branch I am getting 0, so I am getting minus 1. Here I am getting 1 from this branch and 0 from the another branch, so it should be 1 again. Here I am getting 3 from the upper branch and 8 multiplied by minus 1, that is minus 8, so 3 plus minus 8 is minus 5. I am getting 1 from the upper branch, 0 from the other side, so I should say 1 here. Here I am getting minus 1 from here, so minus 1 from this side, 0 from this side, so I am getting minus 1 here. Here I am getting 1 from the upper branch, 0 from the bottom branch, so I should get 1 again. So this way, if you evaluate the x of k, it comes out to be, first of all, I'll write the answer 11, then followed by 1, then minus 1, then 1, then minus 5, then 1, minus 1, 1. That is the DFT of this sequence 1 2 1 2 0 2 1 2. Here all coefficients are coming real, but if these coefficients are coming non-zero, then your answer might come complex also. While solving the DFT coefficients, please note this: when you solve this, you will getting coefficients. And the coefficients are like this. remember there is no need to find x0. X0 we know that is a summation of x of n. So what you have to do to find x of n, you can sum the numbers. 1 plus 2 is 3, 3 plus 1 4, 4 plus 2 6, 6 plus 0 6, 6 plus 2 8, 8 plus 1 9, 9 plus 2 11. So this number can be evaluated by adding all samples. This sample, the middle sample, that you have to evaluate by summing first of all even numbered samples. So from this example you can find out that even numbered samples are 1 1 0 1, and some of these even numbered samples are 1 plus 1 plus 0 plus 1, and minus the sum of the odd number sample is 2 2 4, 4 plus 2 6, 6 plus 2 8. So it is 2 plus 2 plus 2 plus 2, that comes out to be 8. So it is 3 minus 8, that comes out to be minus 5. And already you know that x of minus 4 is minus 5. So remember, x of n by 2 is summation of even numbered samples minus sum of odd number samples. So please refer symmetry property of DFT. So this way you can find out these numbers very efficiently. And remember, when you find these two numbers you can find easily using DFT property. X of 0 is sum of all numbers, x of 4 is even numbered sample minus odd numbered samples. And you have to remember that these two numbers x3 and x5 are always complex conjugate of each other for real sequence. x2 and x6 are always complex conjugate of each other, and x1 and x7 are also complex conjugate of each other. So if x1 is 1, then x7 has to be complex conjugate of 1, that is 1. So verify this. Minus 1 complex conjugate is also minus 1, and this is complex conjugate of 1 is also 1. So this way you can find out, verify your answer whether the answer is correct or not. Please refer symmetry property of DFT, where I have discussed this example, where I discussed this in detail.